Hello, welcome to this lesson of our study of Fourier series. So in this lesson, I have what we call the half range Fourier series. So what the half range Fourier series has is that with that one, the range of x does not include the negative aspect, so it's only the positive aspect, like this. Okay, so 0 less than or equal to x less than or equal to L. So given f of s for this range, the half range Fourier sine series. So we are talking about the Fourier sine series here. F naught of x is equal to the same formula as we saw in the Fourier series, but then here Bn is equal to 2 over L. So note this 2 over L integral from 0 to L is not minus L to L. Remember this. 2 over L integral 0 to L f of x sine of this. So for the half range Fourier series, you take the same limit 0 to L, but then instead of that 1 over L in the total Fourier series, here you are using 2 over L. Okay, it's 2 multiplied by the other one, but then here the limit 2 is from 0 to L. So know this as well. Okay, so for half range Fourier series, this is for your Bn. Your Bn is 2 over L integral 0 to L f of s sine of that. Okay, then dx, I forgot to add that. And also the half range Fourier cosine series is a naught equals that. So a naught plus the one that you know already, but then here too a naught is also given by 1 over L. At first it was 1 over 2L in the full Fourier series. Okay, but here multiply this by 2 and this 2 cancel that, so you have 1 over L. So realize that every one of them, or each one of the constants, is actually multiplied by 2 this time. The same formula, but then multiply by 2. So a naught is given by 1 over L integral 0 to L f of x dx, and then an is equal to 2 over L integral 0 to L f of x cos of this one. Okay, the same cos and that. Okay, I hope you understand this. So these are the formulas you use. Now let's try to find the Fourier sine and cosine series of f of s equals this. Okay, this one is a piecewise function. I chose this because I wanted to show you how to do that as well. Okay, so note that the range, or x is within the range 0 to 2. So there is no negative aspect in this. So this is a half range Fourier series, and here our L, that's the highest one, is what? 2. Okay, so Fourier sine series, we said, is given by this, and so the Bn is also given by this. Okay, 2 over L integral 0 to L. So remember, we are using this formula because of what? The range 0 to less than or equal to s less than or equal to 2. Okay, so first of all, our Bn will be equal to 2 over L. Our L here is 2 integral 0 to L. Our L here is also 2. Then f of x. Okay, f of x here is piecewise, that's why I'm writing it back. N pi over L, which is 2, then x dx. Okay, and 2 over 2 is 1, so I have integral 0 to 2 f of x sine of n pi over 2, then x dx. And now the whole limit is from 0 to 2, but then f of x is not defined from 0 to 2 straight away. It's 2 from the first part, that is 0 to 1, and it's also negative 2 from 1 to 2. So you have to break this integral into 2. Okay, so integral from 0 to 1, okay, then f of x is 2 there, so I have to define that. Then sine of n pi over 2, then x dx, then plus integral 1 to 2. Okay, so you can realize that we started from 0 and we are ending at 2, so it gives the whole of this limit integral. Okay, where is it? Then f of x here at that point is minus 2, then sine of n pi over 2x, then dx. Okay, now if you pick the integral of this, that is integral of 0 to 1, 2 sine of n pi over 2x dx is actually equal to When you integrate sine, you get minus cos, okay? But then remember, you also have to differentiate this, and you have n pi over 2. Then you write 1 over n pi over 2 times whatever you get. So you have minus, okay? There is a minus already, but there is also a 2 in front of this. This time is constant, so I just write 2. Multiply 1 over the differential of that, and that is 2 over n pi. When you differentiate, you get n pi over 2, and 1 over this will give you 2 over n pi. Okay? Then cos, because when you differentiate sine, you get cos n pi over 2x. And this is from, everything is from what? 0 to 1. So when you simplify this, putting x equals 1 first, you get minus 4 over n pi. Okay, actually this is what you have. Let me write it back. N pi over L, then x from 0 to 1. Okay, so if I put n equals 1, I have minus 4 over n pi. I'm sorry, this is 2 cos of n pi over 2 when x is equal to 1. And then minus, okay, so minus, so it becomes plus, because you have to get, let me write it back, minus, then you write minus 4 over n pi. Then when you put 0, s equals 0, you have cos 0, and that is 1. So this is what you have. So in effect, I have something like minus 4 over n pi cos of n pi over 2 plus 4 over n pi. And this in effect will give you 4 over n pi back, okay? Then we have 1 plus cos of n pi over 2. I think this should work, okay? Sorry, there's a minus in front of the cos, okay? So I think I have to erase this part and put a minus there. Okay. So that is it. That is actually it. I think that is it for the first part. That is this part of the integration. They do this part as well, okay? Now with the next one, I will actually speed up. The integral, okay, there's a minus in front of that. So minus in front of this, so I have to write minus 2 from 1 to 2 sine of n pi over 2 x dx. Now I integrate this. I'm going to write it. You use the same approach. Since the integral of sine is minus already, it will affect the minus in front, and you have 2 into, you get positive, so 2 into 2 over n pi, then cos of n pi over 2x from 1 to 2. So when you insert your values there, okay, when x equals 2, you put it in place of this side, okay, and then you get cos of n pi. We have 4 over n pi cos of n pi. When you put x equals 2, then minus, when x equals 1, you have 4 over n pi cos of n pi over 2, sorry. So this is what you have for the other side of the integration, okay? I mean this side, okay? So the final one is this plus this, okay? That is what the what do I call it? The piecewise is telling us. So the first term gave us this, and the second term is also giving us this. So our Bn is now equal to the summation of the two. So I have how do I sum them? Let me go back and check. I think I have to wait and sum something before I do some factorizations. Okay, let me sum this and this. I'm writing this back. I won't write the compact form. I'm writing this, okay? I have minus 4 over n pi, okay, cos of n pi over 2. That's the first part, plus 4 over n pi over 2. Is it n pi? Okay, 4 over n pi. Then plus 4 over n pi cos of n pi minus 4 over n pi cos of n pi over 2. So it means that I can actually factor the whole of this n pi 4 over n pi 4 over n pi out. Okay, I can actually do that. So if I factor it out, the first term bn will actually be equal to 4 over n pi out, and the first term will be minus cos of n pi over 2, right? And the second term will be plus 1. The next term will be let me see. Okay, the next term will be 4 over, okay, this I factored that one out, so it will be cos of n pi, cos of, okay, sorry, plus 1 plus cos of n pi, then minus cos of n pi over 2. Okay, remember all of this is in brackets. Okay, there's a minus this, that, so we have two of them, so this will give me 4 over, I'm doing this, and I will allow you to do the second part. The second part, I'll actually write the answer and then you do it yourself. Okay, this one is equal to, so I have this and I have 1 plus, I'm writing these two first. The cos of n pi, we said already that is minus 1 to the power n. Okay, that is one thing you should know as well. So these are all coming from trigonometric functions. And minus 2 cos of n pi over 2, because you have two of them minus cos of that. So this is actually our bn. So it means that our Fourier sine series f naught of x will be equal to summation n equals 1 to infinity, then our bn, where our bn is 4 over n pi, okay, 1 plus minus 1 to the power n minus 2 cos of n pi over 2, okay, then sine of n pi over 2, then x, because the L here is actually 2. So this is actually the solution for the Fourier sine series aspect of a half range Fourier sine series. And then with the half range, we said the range is like this. Okay, this looks like a half range. The negative part is not there. So this is what we have for the half range. Now let's look at the Fourier cosine series. That's a half range Fourier series, Fourier cosine series. Okay, now the same thing, we have our a naught to be this, I have an to be equal to this. Look at the formulas very carefully, and that our a naught, which is equal to, I'm coming to write them straight away. I'll actually write them straight away. 1 over L integral 0 to L f of x dx will then be equal to 1 over 2, that is our L is 1 over 2, sorry, is 2, integral 0 to 2 f of x. Okay, I actually don't know f of x because it's piecewise. Then 1 over 2, then I have to break the integral into parts. So I have 0 to 1 first, and the f of x there was 2 dx, and plus integral 1 to 2. Okay, so and then the f of x there was negative 2 dx. Okay, so when you do this integration, actually you get something like, let me do it on this same sheet. 1 over 2 into, when I do the first part, I'll have 2x from 0 to 1. When I do the second part, I'll have minus, let me put the minus 2x from 1 to 2. When I put 1 inside, I have actually you get 0, but I'm just doing it 2. When I put 0 here, that will be 2 minus 0, that is 0. Minus, when I put 2 in place of this part, okay, remember this is like this, okay, that we are actually doing for both sides. When I put 2 in place of this one, I'm actually doing them together because this looks simpler. Okay, you can actually do this separately on your own, then do separately for this, then come and add them. Okay, but I'm actually doing them together. When I put 2 inside this, I'll have minus 4. Then I put 1 in, I have minus this minus 4 here, minus, and I put 1 in, I'll have minus 2. Okay, there's already a minus in front, so whatever you put there, you have to negate it first. So with the 2, when I put 2 here, I have minus 4. Then minus, when I put 1 in, I'll get minus 2. I hope you get this. So this will be 2 minus 4 plus 2. And that will be 2 plus 2, which is 4 minus 4. That will be 0. So actually, A naught is actually 0 in the here. Okay, so A naught is equal to 0. Okay, so you do for an, but an is equal to 2 over L integral 0 to L f of x cosine of n pi over 2 x dx. So one thing I will do here is that I will just write the expression for you, then I'll write the answer. L is 2, so 2 over 2 integral 0 to 2 f of x. Since it's piecewise, that's why I don't write it at first. Okay, here is actually L, then dx, and this will be equal to 2 over 2 is just 2 like that. It's 1 like that, sorry. And I said the integral will be, first of all, breaking it at the first limit. Okay, then the function f of s there is 2, and cos of n pi over 2 x dx, then plus integral 1 to 2 minus 2 is here, then cos of n pi over 2x dx. I hope you understand this. Now here you can actually check and see that the last part will give you 0. I think so. Or it wouldn't give you 0. I think not. No, because you are not integrating over a symmetric interval. Okay, so know this. So therefore, when you have to take this integration, do it yourself. Remember, integrate cos, you get sine. It's not negative, you get sine. Okay, you get positive sine, and you have to differentiate here, and then you reciprocate it. Okay, when you integrate cos here too, you get sine, but there is a minus in front of it, so check it very well. And then after doing everything, you have to get an to be equal to, after doing those integration, have an to be equal to 8. Okay, straight away 8 over n pi sine of n pi over 2, and that your Fourier cosine series fe of this half range function is equal to summation a naught plus, but a naught is 0, so we have summation n equals 1 to infinity. Then an is also what? 8 over n pi sine of n pi over 2, then sine of, sorry, it's a cosine actually, I'm really sorry for this, cosine of n pi over 2x. Okay, so that is it for your Fourier cosine series for this half range function. And remember, it was a piecewise function, and know how to integrate a piecewise function with the method I just showed you. Okay, I believe you'll be able to simplify and get your an to be this. Okay, so if you are not able to do, just let me know. If you're able to do too, thank you, and just like it, and also comment in the comment section for me to know that you will actually be able to do. Okay, so you can also try this. This is also a piecewise function. F of t equals t, comma, then within this range, and it's 4 minus t, also within this range. So for the Fourier sine series is given by this. Bn is this, and that this is the solution. Okay, remember, this is the limit, or this is the range, so it's a half range function, and then L is also 4. And know that your Bn will be something like this: 2 over 4 integral from 0 to 4, then your f of t, okay, sine of n pi over 4, then t, then dt. Okay, this is what you do, because you are doing it with t, it's not x anymore. Then when you do, you know how to split it into 2. The integration has to be splitted into 2, and 2 over 4 will give you 1 over 2. Okay, so it will multiply everything after splitting it. So the first integral will be 0 to 2, as is stated here, and then the f of t there is defined as t. So you write t multiplying the sine. Then you go to the second integral, that will be from 2 to 4. And the f of t there is this. So you pick this 4 minus t multiplying the sine. So after doing your simplification and doing your computations very well, these are what you get for your Bn, and that your Fourier sine series, that the half range Fourier sine series, will actually give you Bn to be equal to this and this as your Fourier sine series. Okay, and you go to the Fourier cosine series. A naught will give you 1. Okay, remember our A naught is giving us 1 over L, which is the 4 integral from 0 to 4, then f of t, then dt. That's your A naught. But f of t here is piecewise, so you have to split them according to the range. I hope you understand. You do same for an, then this is what you have for an. Okay, very long like that. And this is what you have for your Fourier cosine series. I hope you understand this. So this is it for, I think, Fourier series. We have a video already on Fourier sine series and Fourier cosine series and the total Fourier series. What we just did is the Fourier series for half range functions. Okay, so it's this one we call it Fourier or half range Fourier sine series and half range Fourier cosine series. Okay, so thank you, and don't forget to subscribe to my channel if you have not subscribed. See you next time. Actually, we are going to use this for our next discussion in the solving of heat equations, Laplace equations, and probably maybe the Poisson equation or something like that. Okay, so see you next time.